So this is ARPANET, right? The internet essentially, right, is just wires. It's just a bunch of wires. If you don't believe me, think about your house, right? Think about your apartment. When you're outside your building, somebody came by at some point and drilled a hole into your building, into your apartment, and they ran wires into it, right? For those of you that have ever moved, the first thing you do is you call the cable company. You're like, what's up, Spectrum Wireless? You know what I'm saying? I'm trying to get some internet up in my house. And they tell you, yeah, no big deal. I'll send somebody there Tuesday between the hours of 8 a.m. and midnight because they're great and the customer service is amazing. Really what it is it's because they ran a wire. It's installed into your house already, and that wire is what connects you to the internet. That wire then connects to a modem, right, which processes all the data, and then what do you connect that modem to? You connect it to a router, right? It is so amazing that in 2018, human beings have figured out how to literally beam, I'm not using it incorrectly, beam bits of data over frequencies that you can just then reprocess on the other side of whatever it is that you have, like a laptop or a phone. It's wild. It's so wild. So continuing on, in 1969 rather, Stanford and UCLA were the first two, right? And what wound up happening was they were like, all right, let's test this message. All right, so a lesson to be learned and something that you should be very grateful for is that all of your demos, just like the one that I'm doing right now, where I obviously started the screen recording on time, is demos will go bad. They will always go bad. The first word ever to get sent across the internet was from UCLA to Stanford, and it was attempted the word login. And they were sending it, it was going through the wire, L went through, it was money, O went through, it was money, and then it crashed. So fun fact, LO, L-O, was the first text message ever sent over the internet. All of your demos will break, and it will be okay, right? Because the first one broke, and they cursed us forever. It's like original sin, right? So basically, once that was established, they figured out a way to connect other computers through a wire so that there would be a network of computers. It was just more than two, right? Otherwise, I mean, how useful would that be, right? So this guy by the name of Vinton Cerf, C-E-R-F, invented something called the TCP. Does anyone know what that stands for? It was like a computer science major in here, right? No? Something protocol, very good. That's exactly what it stands for. Transmission, what was it?
Transmission control.
It is transmission control protocol. Very good. So what that is, all you really need to understand is that it always combines with something known as IP. So you'll hear the term TCP/IP. And to summarize it, because I'm not giving you guys a computer science lecture today, is that it's just a set of rules, right, and procedures that follow in order to correctly transfer data. Right? All the transfer of data is done through something called network packets, right? And the way that works is somebody just literally rips open the wire, takes like your internet memes, and then like shoves it through, and then just blows it through the tube until it gets to the other side. And that's how the internet works. Lecture done. No, that's not how it works at all. So this is kind of how it works, right? So what it does is it actually breaks down, right, all of your data into small little chunks, right, that can actually pass through the wire or get sent over these internet waves, like the frequencies. So we're going to open Google Docs because this is the only way that I figured out how to do this. Unfortunately, I am not a graphic designer, so I don't know how to use Adobe Photoshop. Don't tell anybody. I definitely may or may not have told people I can. So what we're going to do is we're going to simulate it, right, hardcore styles. All right, oh, look at this. Do you know this meme? The roll safe meme? Mm-hmm. Well, now you do. All right? All right, hold on. So, it's embarrassing. All right, so basically what's happening is this, right? Ignore the fact that there's 4, right? I just did it because that's the way Google Slides restricts me to do it. But essentially what's going on is this, right? The internet, through the magic of network packets, what it does is it will literally break down your image, and it'll tell it exactly where to go. So this right here, right, for your image, for your text, for your strings, for your numbers, for whatever piece of data, it'll break it down to these tiny, tiny, tiny squares, right? Probably the size of like this. And then what it'll do is it'll just go, all right, cool. It'll actually send it through the wire, and from here it'll go to grandma's house, right? Because you want to send her memes, because grandma's hipping with it, right? Let's just say, boom, this is like the internet wire, right? Boom, right? And then here, what it'll then do is it'll crop, right, all of your images, and it'll tell it, hey, guess what? Coming in hot. This is the top right part of the image, right? Let's see if I can do this. Boop. Oh, money, right? Sorry, it's like a first-time go over here. So then it'll be like, oh, hey, coming in hot, we got bottom left of the image, right? And then bottom left of the image will go through. And just like that. I'm not going to finish it for you, but then it'll send the rest of it. Once it all gets there, right, the image is completely reassembled. And then once that packet is complete, then you can download that information, right? So if you were back in the day, like dial-up, do you ever remember like when images would load like top to bottom, pixel to pixel across the line? That's what was happening. Your network packets were coming through, right? And essentially each one of those little pieces were getting reassembled to the right place that it was going to go to, right? And that is how internet information, data, images, all that is getting transferred, right? So far, so clear. Any questions on just that concept of like a little bit of the history and how the internet works? Nothing? Wow, you guys are all G's. All right. So flash forward, right, 1991, the World Wide Web was invented by a gentleman by the name of Tim Berners-Lee. Basically, this internet connection, right, on the ARPANET was fairly exclusive, right? You could see that it was only really the universities. So anyone with an internet connection, anyone that is connected to this line would have access to all of the information. And that's kind of like the difference between like World Wide Web and like internet. Is that making sense? All right, you need to be plugged in to this, the internet, in order to have access to all the information. And it's just like a web, right? This is like back in the day, this is 1974, right? It's 2018. There are like millions, these little squares, right? We're just gonna call them nodes. There are like millions and millions of these things, right? Every single one of these nodes is a connection to the internet, right? So you've got my laptop, I've got a cell phone, I've got a second cell phone because I don't do shady things, and just a bunch of like interconnectivity through all these different like lines. So far, so good? All right. Don't worry, if you're still confused about the internet, I've got like really, really high speed animations that I'm gonna show you. It'll be all good. So let's talk about what the internet is not. All right, the internet is not a cloud, right? You've got Cirrus, Nimbus, right? The internet is not one of them. It's not labeled a cloud, all right? So just, if you thought that, just get that out of your mind. All right, the cloud is something else, and we can talk about that later. All right, but bottom line, it just allows two computers to communicate. And we talked about TCP, right? So does anyone have an idea or understanding of what IP is? Like Internet Protocol, yes.
Like IPv8 or something like that, V6.
It's V6, yeah, generally.
Are we like moving V8 and skipping V7? It's a weird thing like that.
Yeah, it's the same way that Xbox like to count to Xbox 360, and then count it to 1. Yes, exactly. You know, Windows did it too, right? Windows 95, Windows 98, Windows 2000, XP, let's not talk about Vista. And then all of a sudden it was like 7. Yeah, you're like, cool, cool. And then they had Windows 8, right? Super fail. And then we don't talk about 8.1, right? And then did 9 exist? I don't know, but Windows 10 is out, right? That's great. So bottom line is, let's talk about IPs, right? All right, note to self, that joke did not land. I'm just gonna. All right, so what IPs are? Think about it, right? It's just think of IP addresses as the same as your physical address at your house, right? So if you were gonna get like a delivery, you're gonna buy something on Amazon. Where would they send it to? Right? They're going to send it to your house, right? They're going to send it to 123 Very Real Street, Anytown, USA, right? The IP address is very similar in the sense that your IP address is registered to your computer. That's how when, here's like, you ready for that high-speed animation I was telling you about? By the way, that animation, it's just gonna be me. So I'm just gonna drag it through, right? So like, you're the client, right? And the reason you're the client is because you are not directly connected to the internet, which is this wire right here. This wire symbolizes the internet. And the reason you're not directly connected to it is because we have what is known as ISPs, right? Internet service providers. So you have like Cox, Comcast, Optimum Online, Spectrum, whatever you have it, whatever you name it. They allow us connection to the internet. They're sort of like that third party that connects us to it. But Google, like Gmail, will have like a direct line to the internet. And all it is this right here is just someone's computer with a hard drive that's just storing information and data, right? Like, so if I were to go to google.com, right, what's gonna happen is I'm gonna go, my client, right, my laptop, is gonna hit my ISP. ISP can also be for your phone, right? So you've got T-Mobile, Boost, Cricket, Verizon, Wireless, right? They connect me to the internet. It beams to the satellite, right? I'm requesting information, right? I'm telling my phone, go to google.com, get me something, right? I'm gonna get something from it, right? It's gonna go back down to the line, right? Because you know what signal towers are, right? It shoots to space, hits the satellite, comes back down to a signal tower. That signal tower is connected to this line, the internet, and then that line is gonna route to Gmail, all right? Now I can send a cool email like, sup, Aunt Ruth, how's it hanging? It's your boy, Evans, love, grandson, because that's how we talk, right? And then what it's gonna do is, Gmail, when I hit send, right, I'm gonna send information, right? We're just gonna call that a post. Just bear with me. Doesn't really sound sexy, but that's what we call it, right? It's a post. And then it's gonna go travel back through the internet and it's gonna sit on AOL.com because Aunt Ruth is in 2018, right? No? AOL? Yeah. That joke also fell flat. Just gonna make a note of it. All right. And literal lines will connect to her desktop at her house. So when Aunt Ruth logs in, she's gonna connect through these lines back to the AOL server and then download my very sweet message, bake me cookies, and everything's gonna be great, right? That's conceptually what's going on, right? Does anyone have any questions on that so far?
That's a get action.
Aunt Ruth getting email is a get action, yes. Now, if she were to type another email and send it out and put out information, right, that's gonna be a post, and we're gonna talk a little bit about that. But so far, any questions on like how the internet's working, right? We talked a little bit about IP addresses, right? Let's talk a little bit about routers and stuff. Are you ready for one of my famous Evans Wang animations? So let's just say you're chilling, right? It's you, right? And your boss or your friend, right? And your boss is doing the right thing, right? Your boss is on marketresearch.com trying to make money for the company. But you're on Bookface, right? Updating your profile, sending tweets, hanging out. What's happening here, right? How do I know that when I update my Facebook, I'm not gonna get market research back? When I go to facebook.com, like it doesn't get crossed up somewhere along the lines.
You and your boss have different IP addresses.
Yes. Anyway, exactly, we have different IP addresses. So my IP address, right? Who has sent like snail mail here? You sent snail mail? Wow, very old class in here. Yeah, well, let's Google this. I need to show you what it looks like.
And
Yes.
you draw those.
What? I don't know. I don't know if I can. My drawing, believe it or not, worse than that. Right? That's why I became a developer. Yeah. It was very difficult actually, because I'm not very good at Googling. So, oh man, I didn't pre-screen this actually. I probably should have. Anything can come up, you know? Demos, you know what I'm saying? All right. This analogy is falling on its face, so I'm gonna leave it alone. But the bottom line is, right, back in the day in snail mail, you would write the physical address, right? Like 123, this is your street, Anytown, USA. You put a stamp on it, which cost money, right? You had to like lick it or whatever. And then in the top left corner, you had to put your address. In case it could not get delivered, it would come back to you. Also, if you sent out spam back in the day, people would know who to write back to and be like, please stop sending me these AOL 100 hours of internet for free discs. You know, please stop doing that. No, man, oh, whoa. Oh, showing my age over here. I'm just gonna delete half these jokes. So, bottom line is, right, you're gonna send a request. You're like, hey, I wanna go to facebook.com. That's gonna go through your router, right? Ultimately through your modem, and it's gonna contain a lot of information in your TCP, in the layers of the request, right? It's gonna hit your ISP, it's gonna connect you to the internet, right? That's gonna direct you which way. Oh, I need to go to facebook.com, so it's gonna shoot me left here, I'm gonna go here, I'm gonna tweet, I'm gonna post, I'm gonna tell everyone how happily married I am, but, you know, we don't know. Anyway, so you come back, right? And you look at all the cool photos of your friends at like Bali, and you're sitting here teaching at like Fine Art School. You know? No, I'm just kidding. But anyways, you come back, right? And it comes back to you because it knows to send the request back to your IP address because that was like the original request, right? Is that all making sense? That way, your boss never sees you, you know, tweeting. That'd be rough, right? It'd be real rough. You know what I'm saying? Yes.
So I'm kind of confused about like, so Facebook and marketresearch.com, they don't go through like an Optimum or something like that. They're just directly hooked up to the web wires.
I mean, you'll host your information in the same way that you can like create a server that's connected to the internet all the time. And we're going to do that today, right? And I'll explain a little bit more about.
Without going through an ISP at all.
No, they'll go through like an ISP.
Oh, so Facebook also has their servers go through like.
Yeah, but it's hooked directly up to what is known as like the internet, and I'll explain here in a little bit. But I kind of know where you're going. So to give it to you really quick, your question is like, is Facebook directly connected to the internet? Are they going through an ISP? Right. Facebook basically has a bunch of hard drives somewhere. Have you ever heard of the term server farm? Right, where they have like all of your information, right? All of that information. You ever seen like, oh man, like all these cables? Like let's just Google server farm. We don't need roll safe anymore, all right? Server farm. Right, basically it looks like this, right?
Have you seen like the meme where it's like that picture? It's like live look at Wall Street reacting to today's market. Just like that.
Yeah, all of these lines, they're hooked up to the internet. All right, that's how they're all connected. So if each one of these bays is like one of these, except it doesn't have a screen on it. It's just holding information. So when I connect to it, it's gonna give me back what I asked for. And how does it know to go to each one of these? The specific one. It has a particular IP address, right? And we could prove it, right? Everyone knows, right? Who here, man, all these jokes are gonna fall flat. Do you remember anyone else's phone number? Yeah? Not your own, obviously. You have one phone number you remember, right? I grew up in a time, I'm very young, where you had to remember everybody's phone number. If you didn't know it, you couldn't call them. That was it. And so this lovely idea of address book came down, right? It was like, I'm going to call David at 867-5309. Actually, it's Jenny. Thank you, wow. Bro. Anyways, it's just a really old song, right? Anyways, but it's so much easier now on your cell phone, right? Where you can just be like, oh, I'm going to pull up phone book and I'm going to call like Bay, right? And then you just click Bay, right? And it just starts dialing, right? Because everyone does that. It's, I don't know. I'm trying to be hip and relevant. Stay with me here. And you basically click Bay, right? The number doesn't even come up. It literally says BAE dialing, and then it rings and somebody picks up, right? That's what we've done with the internet. Like we can go to Facebook.com, right? Don't worry, I didn't log in. I don't really have a Facebook account. Try looking me up. So, or I can go to Google.com. I can type in the name that I can actually remember, right? Believe it or not, every single one of these you can go to by IP address. So let's prove it. Here, ready? Let's open up a network utility. All right, all of you Mac users have this, and you can run something called traceroute. Right, I can go find the route for Facebook, and it's this right here. This is the IP address. So nobody is actually going to go like, oh, hey, real quick, I got to update my Facebook, and then type in the address bar and go, all right, dog, I'm here, we in there, let me just send this post real quick. All right, 31, 13, 71, 38. Just going to update my Facebook, right? But it'll go because they're all IP addresses. That's all it is. There's also ports and stuff, but like the internet usually runs on 80 and it just defaults. So if I wanted to, right, I can run like this, and then I think it's like a semicolon for the port, and I can run 80. And that's going to give me the same thing.
So does the domain actually connect to anything, or does it just immediately connect to that IP address?
The domain, there's a little bit more of a complication in the layer, right? So you send your GET request, right? It goes to your internet, it hits like a DNS, and that is what kind of transcribes what Google is to the IP address, and then it runs to that IP address. It gets the information, and it serves it back to you.
So it just kind of unifies it?
Yes. Yeah. And that's how everything is under the hood, right? So if we go back to my high-speed amazing drawing example, I put some amazing IP addresses on here, right? They've since been dated since I pulled this image, but that's really what it is, right? That's kind of conceptually like the broad overview of how the internet works, right? Did anyone like learn anything? Like, it's like a little bit good? Just a little bit?
I have another question, actually.
Send it.
Who owns that internet wire?
That is a very good question. You know who knows?
Google.
Attaboy. That's right.
Tests.
Right. Google will tell you, but right now, I mean, how you can run cable will be determined by a lot of different regulations. I don't want to get too crazy, so I definitely am going to hit this pause button. So, the next thing we're talking about is, now that you understand a little bit about how like the internet is kind of working, now I'm going to like open your mind to every single web page on the entire planet. So, every single web page, you can actually see everything that's on there, right? There's no secret to it. Everything is essentially open source. Who has hit inspect before? All right, what does this do? I heard a lot of murmuring. It generally shows you, right, the source code, right? So you can start messing with anything you want, right? Have you guys all written HTML, right? This is just your HTML tag, right? Look, each one of these, if I wanted to, will show me the different parts of that website. So like if I wanted to get into this div, right, and then I get into this div, I can see, what is central notice here? Okay. So I can see this H1 ARPANET, right? I can literally edit this if I wanted to, right? So like this is probably ARPANET. I can put like Wangtron's secret stash, and it'll change. Right? Because that's just how the HTML works. I mean, it's not persisted. Like if I refresh it, it'll go back to ARPANET. But that's basically how the internet is. Like all of this is just an HTML document. You've all written this, right? Then you've got like your styles over here, right? So let's say World Wide Web. Here, let's go to a different website. Inspect. Right? So you have like styles here, right? If I wanted to. Like here for this, look, font size, I can just jam this up if I wanted to. All right? And then if I was really bad at CSS, I can just add a new class, take this, drop the class here, and then boom, my font size is now bigger. All right? That's just like a little pro trick. But the point is, everything is just served up in like HTML. So when I make a GET request, right, to 31, 13, 71, 38, port 80, I'm going to get this. Right? I keep saying GET request because that's exactly what I'm doing. I'm asking it for information and I'm getting something back. Right? Do you remember like the server farm? Let's just say this one particular server is Facebook. It's like the 31, 13, 70, whatever, right? On this hard drive sits a file called login.html. So when I go here I'm going to see this exact HTML. This is what I'm going to get back. My browser, the client, Chrome, is going to interpret all of this HTML, and then I'm going to see this sexy GUI, right? This like nice page that has the CSS, the JavaScript, and the styling to it. All right? Is that all like kind of putting it together? Now, if I wanted to sign up, all right, I can like put in my name, put all this information. When I hit sign up, I'm actually going to be doing what? What's that thing I called? I'm going to make a post request, and where's it going to go? Huh?
Another address.
Yes, it's going to go right to that IP address, right? And that server on that code, without a screen because the code's already on it, it's going to take it, right, as parameters, right? What are the parameters that I'm sending it? I'm sending it a first name parameter. I'm sending it a last name parameter. I'm sending my phone number, right? And I'm sending my birthday. And I'm sending one of these binary genders, right? And then it's going to do something with it. What's it going to do? It's going to process that information, and then it's going to say, okay, great. I've logged you in. I'm going to save your record to the database, and then I'm going to serve you some new thing. And what's that? That's probably going to be the actual page that I'm logged in. And then that page is going to say what? It's going to be all this HTML, except it's going to be, you have no friends. Why don't you make some? Loser. Right? That's probably what it's going to say. Yes, sir.
Is my Facebook page saved on a server somewhere, or is my info saved on a server and it's pumped into like a default HTML profile file?
Yes. To one of them. And that's the difference, right? I want to get into...
Yeah, I was just going to say, well, we're going to talk a little bit more this afternoon about like, how do I take some data in my database, right, and dump it into the HTML.
Right. And so to answer your question, Facebook is known as what is known as a dynamic website. So that means that it can, in fact, make a call to a database and pull your information. As opposed to static, which means that, here's a static website that I built actually. Here we go. Right? This is just HTML. Right? This is a static website that I did and I got paid money for, and that's great. So anyways, it doesn't really do anything, right? I mean, there's like an email form, right, which is cool, right? But that's it. It just serves up information. It doesn't really go anywhere. So this is static, right? But whereas if you were to go to Airbnb and you're like, oh, hey, I want to rent something in like Cozumel, I'm going to have to put in parameters like the city, right? Maybe like the zip code, how long I'm going to stay there. And then it's going to give me back. I need to post those params, and then it's going to give me back, right, something else. It's going to give me back all the listings within that area. If you notice on Facebook, right, if you strip away what friends belong to you, how different does your website look from anyone else's, your profile page? Aside from your profile picture and all your friends, how different does it look? It looks exactly the same. So what it does is it takes some sort of template, right? And then it makes a call to the database, and all of your information, it spits in there. And I'm going to do that for you guys today.
So does Facebook have like a join table? Like one has friends, friends.
Does Facebook have a join table? Oh, yeah. Yeah. I could not imagine Facebook having individual queries for all like 8 million of its like users. That would be miserable.
I know, like some higher level.
Oh, I mean, they probably do it without SQL. Yeah. You know, they use like a different database schema. But yeah, essentially it will be plenty of join tables because it's going to be, you know, like Evans Wang, like select star from tables, Evans Wang, where friends are, you know, like X amount of distance, and like join the table where like, and then it does all this like sorting where like first name is like A or whatever. Or like if I clicked on their profile a lot, it'll cache it and it's like, oh, you must be best friends with this person and not totally a stalker, so that that person's feed always comes up first. You know, there's like algorithms in there, but that's essentially how it's working, right? So I want to introduce you to something called Postman, right, or woman. So what Postman is an application that allows you to do a lot of amazing things, right? One of which is called testing. All right, I know my amazing testing lecturer just made you all thrilled to do tests. All right, so what it does is, what you're going to see here is this is just the GUI, right, the interface for it. I went to flatironschool.com, right? That's all I did. I went and I got a GET request to flatironschool.com, right? Don't worry about all this for now. This is the body, right? This looks exactly the same as if I inspected Flatiron School. This is like the pretty HTML. All right, raw HTML, this is all of it just condensed so that it could be as small as possible as a file, right? This is what gets sent over on network packets, right? And then your browser interpolates it, and then it basically makes it this so that you could read it in the inspector. But computers don't need GUIs, right? They're just all like, here's all the data, great, got it, thanks, let's do this, all right? This is it. This is the HTML without any of the CSS, any of the JavaScript, any of the styling. This looks like all of your basic websites, right? This is just pure HTML. So that's what it's really doing. I mean, if I want to click one of these links, right, what happens?
Still work.
Oops.
Should. It should still have a...
Yeah. Well, right. So what it's going to do is when I click one of those links, I'm asking for information. The question I want to know is, did I send any information over? Am I passing in any params? So what kind of request is it? It's a GET request, right? Once I start passing in params, right, then I can say that it's a what kind of request? Post, right? I can do that. I can test. I can put in params if I wanted to, and then essentially go to like a submit button if I wanted to, and then I can test my website without actually going through and like clicking through. So Postman is like an amazing suite of tools that you can really use. You'll get more use out of it as you do Sinatra and Rails later on this mod, and like ultimately in React as you test your APIs. But that's basically, I just wanted to demonstrate what was happening, right, with the network packets and breaking everything down. And you're making GET requests. So the next main thing, all right.
Question. So if you have a post request, does that mean that the site that you're going to is dynamic as opposed to static?
If I do a post request, not necessarily. So for example, back in the day, they used to create separate HTML files for every single item that was on your website. So if you submitted like a search thing, it could search for all the files that are in there and then just serve you up whatever HTML file you looked for.
So like reload a whole page of info from whatever you search for?
Yeah.
Rather than just that portion of it?
Yeah. But generally speaking, in 2018, if you're making a post request, your website's probably dynamic. All right. Same.
What was the last part?
If you're making a post request, the website's generally probably dynamic. All right. So the last thing I want to show you is something really cool. Who knows the MDN docs? All right. Have you been here before? So this right here, the Mozilla Developer Network, this is your best friend. Right? This is going to tell you everything you need to know about all these main things, right? It's kind of like all the methods. Here we'll talk about HTTP. All right, let's get rid of the console here. There's cookies in there, all right? There's caching, authentication, CORS, big deal, which you'll learn about later on, all right? So there's headers, right? There's response status codes you learned all about, right? Like basically, if you go to a website, right? Let's hit inspect. Right, I can go to network, right? If I hit refresh, it's going to download every single thing here, and it's telling me 200 is what? 200 is thumbs up, good to go, right? No problem. But some websites you go to, oh, actually this website's perfect. Huh. Some websites you go to, you get like 300, right? 300 just a redirect, meaning it was originally located here, but it's actually over here. 400 is what? Right, some sort of error. The most common one is 404, which is file not found, right? And so what you'll do is you'll write in your code, you're like, oh yeah, you know, I'm gonna put this picture in here, it's gonna be awesome, but you have a typo in the name of your picture, and you'll get a 404 status. And it'll say, this is the coolest picture ever, 404, right? File not found, just kidding. But what I wanna connect here is very important, right? So, there's a lot of old school DT in here. Are there any links? what's gonna happen is, like, if there are images in here, like this image, all right, like this image over here, how do you do images on HTML? Yeah, there's like an image tag here, right? All right. Wow, that's not an image?
Can you search for IMG?
I can, but I'm kind of looking for something. That's fine. So you'll find IMG, right? And what is the first attribute of IMG? Source. So what it's going to do is it's going to actually tell you to go somewhere else, download that image, and then put it right there in that tag, right? And in network, you can kind of see how that's happening, right? It's going to download like all the images. It's going to tell you 200, and it's going to tell you it's an image, and then it put it in there. You following along? All right, cool. So I just want to talk about CRUD real quick. CRUD is going to be one of your favorite words, all right? And it just stands for create, read, update, and delete. And all it is it connects directly with the 4 or 5 main methods that HTTP requests kind of respond to, right? So you have your get, which is you're just asking for information. You have your post, which means that you put in the parameters and you're getting information, right? Put and patch, all right, means that you want to update something in the database, but you're still passing in params. So you ever like forget your password and you want to update it? That means that when you post those params, you're actually trying to update something in the database, as opposed to when you go to Google and you're all like, you know, why is the sky blue? Am I updating anything in the database? No, that's just a regular post. But put and patch are special post methods, right? And that's why they're called that. Meaning later on, when I go log in again, my password is now my new password. I've updated something in my database, right? Put and patch. There's a slight difference between them, and bonus points for anyone that can tell me what the difference is. Put and patch.
I'm just guessing.
Go for it.
That puts add something or adds or delete, whereas a patch replaces something existing. But that's just the one.
Very close, Luke. You had it.
No, I was gonna guess.
Okay, so put and patch, and I'll let you figure out which one is which. Right? Is let's just say you have a database, right? You have a table, and there's like 4 or 5 columns in there, right? One of them, put or patch, is going to update that entire row, right? And the other one will update only one field. So for example, right? Let's just say you have a profile, right? You want to update just your password. That's one column in your user table, right? You have your username, you have your first name, your last name, your email address, then you have your password, and then you have all this cool data, right? All my friends. Let's just say I broke up, right, with somebody, then I just want to delete that one row, right? Like I'm no longer friends with that person, right? Said put or patch. I'll let you figure it out. So otherwise, I have to like basically put in my name again, put in my password again, put in my email address, and I update all of those columns, right? The whole table. All right. So that's CRUD, right? Create, read, update, delete. Those are all the functions you're ever really going to do on the internet, because that's all you're really going to be doing, right? Like if you're on Stack Overflow or you're on Slack, you're just going to create a new thread, right? You're going to read it because you want that thread to come up, right? You can edit it. It's like, oh man, actually I didn't mean to say that. You can literally hit edit message, right? And then if you wanted to, you're like, maybe I shouldn't have said that. You can delete it, right? That's all the main functions, right? And that's gonna literally go to get, post, put patch, which I'm kind of saying are special post methods, and then delete. Delete is also a special post method because you're sending params, right? You're telling the system, hey, I'm gonna update something, but am I really updating it or am I just wiping it? I have to send some sort of information over to the system, and that's gonna wipe it, all right? Like my Facebook account, because I knew I was gonna start teaching. You guys are all gonna look me up. So I was like, nah, dog, I'm a ghost. So that's really about all there is to know about kind of like CRUD, HTTP requests. Something interesting happens, right? When you're online, do you just go to one website and you're like, oh, this is it, done. I'm gonna open youtube.com and just put your phone away? No, you're gonna search for something, right? That's a post request, right? And then you get all the videos back, and then you click on the link that you want, which is a GET request, right? And then you watch your video, and then what? And then you're like, you know what, that was cool, I need to go back to work, learncode.com, which is a GET request, right? And then if you're searching for a particular module and you put in the search bar, you hit enter, that's a post, right? You getting it. But what do you notice? Pattern. There's like a ask, receive, ask, receive, ask, receive. That is what is known as like the request response lifecycle. So you're always asking for something and then you're getting something. You're asking for something, then you're getting something. Even if it serves you back like 404 error not found, like file not found. All right? Any questions on any of that?
This is Mozilla Developer Network, by the way.
Huh?
This is MDN.
Yep. See? So something I want to explain to you, right? This HTTPS, right? This is the protocol. If you know anything about like email servers, there's like SMTP, right? That's the protocol. This right here is the domain, right? So I'm in like mozilla.org. And this right here, anything after is what is known as the path. The path, the path, the path. The path is going to be so important to you because the path is what explains to you exactly what resource you're going to get. This is points to the exact get that you're getting, all right? I'm going to fly through Rack because you've done it already. I just want to explain something to you, talk about problem-solving process, and I'll let you break for lunch. I'm sorry I'm going to let you go a few minutes late, but let's take a look at this code that I wrote, all right? This is not code. What the? Oh, here it is. Boom, right? So what we got here? We got an app, right? It's just going to call itself. I'm going to instantiate some new songs, right? I wrote this out for you. This is the request. This is the response, all right? It just opens a new rack request, new rack response. If the path matches songs, right, then I'm going to have all my songs, right? And we'll just take a look at song real quick. It's just a collection, right? Nothing fancy because I'm awful at code. And what it's going to do is it's going to map over them. For each one, I'm going to make an LI tag. I'm going to interpolate the song, and then I'm going to close the LI tag. And then I'm going to join it all together. I'm going to write it to this bomb song list, you know what I mean? And then each one of the song list items are going to iterate through as an LI, right? Kind of cool. Or I can go to path match artists, cool artists, or otherwise just no such website. Response.finish. This is important. I think some of you have been asking questions about this, but really this is to close out that response. You're requesting something, right? In the response request lifecycle, we talked about the network packets, right? The network packets come back, and until they're all assembled, right, we don't know if it's finished, right? The analogy that I gave earlier was that Amazon, you buy something on Amazon, right? It texts you. It's like, hey, I sent it. And then 3 weeks later, you get a text that says, I had to send it back to sender, could not deliver. And you're like, what happened? Why didn't I get a text that it was delivered? Why didn't anyone tell me that the package was delivered? This is ridiculous. This line right here, response.finish, tells you that response is done. Go get that data, right? I'm going to request something, right? And then they're going to do something with that data, send the response, but I don't really know to process the response until they tell me, hey, that response is done, go ahead and process it. Is that making sense? So that's kind of like the end statement for a method that Elvin greatly pointed out, right? So you put def, method name, and you hit end. Response.finish is like ending. Lets it know that the method's over. All right? So let's do this, right? Quick thing is, let me pull up the terminal. So something called shotgun, which you'll learn about. All right, let me make sure I'm in the right directory. Uh-oh. What directory is this? Right? Yeah, let's see. CD Flatiron School. Oh, come on. CD Flatiron School. What is it? You can see it up there, right? Lectures, starter code, right? Rack. All right, cool. So now I'm going to run shotgun. What's in here? Oh, let's see, intro, sorry. Now I'm going to run shotgun app.rb, right? So what's going to happen, right? This is the server that you all know and love. Right? It's basically localhost. Right? Which localhost is one of those cool aliases that we used. Right? As opposed to like google.com, like localhost is like the name, but you can go to 127.0.0.1, right? Oh, no such website, homie. What do you think happened? It's because I have to have my path match songs. All right, so let's make it match. So bomb song list, right? Nothing's here. You got any? Name some songs. What are you guys listening to right now? Shake Off. All right. Anything else? What else we got? Is it me you're looking for? What else? I'm not putting that in there. I'm just kidding. I'll put it in there. All right. So what happens if I refresh this? Why has this come up? This is why you're very close. I didn't want to like shut you down. The connection was closed. That's why it's being served up. I wanted to point out something, right, about process, and then I'll leave you with this. And that is, if I'm not getting any error messages, all right, like I'm not getting any error messages. This is working exactly as coded. What do I do? Huh? Yeah, but where? What's wrong? It doesn't say, hey, error Ruby line 14, missing end statement. What do you do? You could write tests, right? Absolutely, but we want to test it. We want to figure out what's going on, right? So I can, in fact, go through all the LIs, right? But here, know what your code is doing. What are you trying to do, right? I'm having H1, that's there. The UL is there. All my list items are there. But for whatever reason, this list object is not coming up the way I want. So let's dig into it, all right? What is this list object? It's the actual object. All right, so what I need to do is I can call what song.name. All right, and then boom, that should be good. All right, so this is all about why Mod 1 was so important. It's all about that process, right? What is my code doing? Where can I go to find it? What is necessarily quote unquote wrong? What should it be doing? Right? And so Rack right now is running my server.
Unless you refresh the server.
Shotgun allows that hard refresh reload. That's why I like Shotgun as opposed to Rack Up. Right? Right now, huh?
Shotgun is always having a connection between your code and.
Yeah. Yes. So right now, Shotgun, right, is running this server. Right? I'm connected to my own pseudo internet, and then I'm making GET requests to my own server. Right? So imagine, right, I had all this amazing code, right? And let's just say I'm not hosting it on localhost. I decided to host it online somewhere, right? I wanted to connect it, leave it. Can I do anything with my terminal? Right now, can I do anything with my terminal? The answer is no, I can't do anything with my terminal. The server is running. So what I can do is I can just rip this monitor off, shove it in a rack somewhere in a server farm, and be like, all right, that's the coolest website ever. I'm out, dog. Later. And then except I can throw 1,000 of them in there. So anytime someone wants to come to my IP address, right, or bombsongs.com, they'll get this website. And that's how that internet is working. Why there's server farms, what a server is, right, how to connect to it, what it's serving up, and all that, all right? Does that all kind of click? All right, listen, it's about 12:10. I'm sorry, I'm about 10 minutes over for lunch. If there's nothing happening, can we just let them come back at 1:10? Is there anything happening at 1 o'clock for you guys?
This lecture is going to be
Oh, like if they come, yeah, that's fine.
All right. All right, great. So take your hour for lunch. That's all I got for you guys.